Yeah, in the quiz, I see a lot of difficulties in understanding balance and stability. Right, so this is not really about aerodynamics. So I didn't kind of emphasize it enough in the lectures because I thought this was more general mechanics rather than aerodynamics. But I feel like the most type of errors in quiz 2 is actually not specifically about aerodynamics, but after you figure out the forces due to aerodynamics, how to judge is the force going to lead to stability or instability, right? That seems to be the most common error I see in the quiz. So let me just give you two examples, actually the two problems in the quiz. Okay, the first problem is if I have a fairing, right? So I have a pretty blunt fairing, and the cylinder is inside the fairing, and the fairing can rotate around, I think, 0.22 or 0.23, maybe 0.23 times the chord, right? How do you determine if the fairing, if it's free to rotate around the cylinder, is it stable or is it going to flutter? There are two types of answers, and I think there are two types of considerations. I think both are good. One is the flow laminar or turbulent? If it's turbulent, it's going to create a little bit of vibration, right? So that's good. Another consideration, actually, it's going to cause even more vibration, is like, where is the center of lift if the fairing rotates a little bit? Okay, if the fairing rotates a little bit, the airfoil is going to be at non-zero angle of attack. And from the X-foil calculation, we see both the lift coefficient at 2 degrees angle of attack and the moment coefficient at 2 degrees angle of attack. All right, so how do we figure out the center of lift? By combining the lift coefficient and moment coefficient. That's question one. And two is that when we figure out the center of lift, how does that determine the stability of the fairing? Okay, question one. Did anybody, I know like there are many people who got it correct, many people didn't get it correct, but for the people who didn't get it correct, did you go back and look into how to determine stability, or you don't have time? No? Okay, anybody wants to answer this question for me, right? How do we determine the center of lift if we have CL and CM? Yes? Is it CM over CL? Why is it? Okay, that's actually pretty correct. So let me just launch Xfoil and give you a few examples. So first example is, let's say, a very thin airfoil, right? We know thin airfoils, they have the center of, thin symmetric airfoils have center of lift at where? According to thin airfoil theory, the center of lift for a symmetric airfoil should be at where? I think that's something most people got it correct in the quiz. So can you just answer me? Yes? At the quarter chord, right? So if we take a Naka 0004, for example, let's put at 2 degrees angle of attack, right? So the moment coefficient is very, very small, 0.0007, right? So that means if you take the moment coefficient divided by the lift coefficient, it's actually going to be very, very close to the quarter chord. So the moment coefficient is the moment around quarter chord by definition. However, when you take a thick airfoil, so let's say Naka 00, okay, so first of all, let's take a non-symmetric airfoil, let's say a 2412. If you put it at the 0 zero CL doesn't work. So if you put it at alpha equal to 0, so now what you see is that Cm is actually, it has 3 non-zero digits rather than only 1 non-zero digit, right? That means the center of lift is actually not very close to the quarter chord. So actually being minus, right, being a negative means a moment that tries to raise the head or tries to lower the head. A positive Cm is always by definition like upward, right? A moment that's trying to increase your CL. So a negative Cm is a moment that tries to pitch your nose down. Okay, so this means that if the lift is at a place where it tries to tilt your nose down, where is going to be the lift? Right, that's, yes, it's behind, right? A positive lift that's trying to tilt your nose down should be a lift that's downstream of the quarter chord. Okay, so if you divide this number by this number, you get actually about 1/5, right? You get about 1/5. So the center of lift is 1/5 of the chord behind the quarter chord, somewhere pretty close to half of the chord. Now, if you take a thick airfoil, let's say even a symmetric airfoil, if you take it pretty thick, right, and turn on viscosity, let's say 10 to the 5. If you take it to 2 degrees angle of attack, doesn't converge. Okay, now it's converged. Now the Cm is not going to be 0 because it's no longer a thin airfoil, right? So in this case, the Cm is again negative. Okay, a negative Cm means again it's trying to tilt your nose down. So the center of lift is behind, is downstream of the quarter chord, right? And if you do a division of how much downstream, it's maybe 5% of the chord downstream. So maybe the center of lift is going to be at 30% of the chord. All right. So this kind of thing is going to tell you where the center of lift is. Now imagine I have a cylinder over here and the fairing is free to rotate. When it is at 2 degrees angle of attack, is the trailing edge rotated up or down? So let's say if free stream is perfectly horizontal. Yeah, 2 degrees means the trailing edge is over here, right? And there is a lift that's pointing up at 30% of the chord. So if the center of the rotation is at 23% of the chord and the lift is at 30% of the chord trying to tilt up, is that a stable configuration or unstable configuration? Still not sure? So it's free to rotate around here and a lift is trying to push the tail up, right? If the lift is upstream and trying to push it up, it's trying to push the head up and the tail down, that's going to be unstable. If the lift is downstream, right, as the tail moves down, the lift is trying to push the tail up back again. That's a stable configuration. Right, does that make sense? Yeah, an alternative point of view is that, okay, so if I'm centered at the quarter chord, okay, when the tail is rotated down, so now I'm fixing my origin at the quarter chord. Okay, I get a positive lift, okay, at the quarter chord plus a moment that's trying to tilt my head down. At the same time, the center of the cylinder needs to counteract the lift force I have. So the center of the cylinder needs to apply a downward force to my fairing, right? Okay, so both the moment due to aerodynamics and the moment due to the center of the cylinder fixing my fairing at the same place, they are both going to have a effect that's trying to tilt my fairing back. Does that alternative analysis also make sense? Yeah, so this is how you reason about stability. So I think this week you also have to do that on your own airplane, right? So you designed how big the wing is. Of course, we need to iterate on that, but a key thing you need to figure out is where the wing is relative to the fuselage. Okay, and if you have a horizontal tail or canard, how big they should be in order for the airplane to be stable. All right, questions?